graphing of rational functions and also polynomials. So starting off with x plus 5 divided by x squared. Here we know that the vertical asymptote, the x values that we cannot have, are when x is 0. We also know that the horizontal asymptote will happen as x approaches infinity, and I'll actually just write this one out. As x approaches infinity, well, as x approaches infinity, my function x plus 5 over x squared is going to approach 0. I can see that because my denominator has a larger degree than the numerator, and so this is going to get considerably, the denominator is going to get considerably bigger than the numerator. It's going to grow much faster. And my root will occur, there's only going to be one. It's when x is negative 5. There it is. Quick sign chart will tell me, I've got it at negative 5 and at 0. Quick sign chart will tell me that if I am to the left of negative 5, that my function is going to be negative. If I'm in between negative 5 and 0, my function is going to be positive. And when I move to the right of 0, my function is also going to be positive. So graphing my function, I know that I am, here we go, I know that it is negative to the left of negative 5. As it hits negative 5, it goes through, it's positive up towards the asymptote. To the right of 0, it is also positive, and we'll head towards the horizontal asymptote, just like that. X minus 3 squared times x plus 2 times x squared. If I want to sketch a graph of a polynomial function, I need to know the basic shape. So this is going to be a 5th degree polynomial. So its basic shape is going to look like that. It's got a positive leading coefficient, so that's still how the basic shape looks. And then I need to plot my roots. My first root occurs when x is positive 3. I have another root when x is negative 2. And the last root when x is 0. And now to graph, I know that I'm coming up from the left. At negative 2, this factor that gives me negative 2 that has multiplicity 1, so it's going to pass through. At 0, this has multiplicity 2, meaning that the factor here doesn't change sign, it's squared, so it will bounce back. And then at positive 3, again, squared, meaning it won't change sign, so I'm going to hit at 0, bounce up, hit again at 3, and bounce back up. Finally, 2x squared plus 16 divided by x minus 2. X values that I cannot have an x value at positive 2. That would make my denominator 0. As x approaches infinity, so my horizontal asymptote as x approaches infinity, it might be helpful to simplify this function. So if I divide, what will I get? Well, I will get 2 plus some remainder, that's for you to figure out, all divided by x minus 2. So as x approaches infinity, this function, f of x, well, what's going to happen to it? Notice that as x approaches infinity, this last part will tend towards 0, so I'll be left with 2. So my function will approach the value 2. So that's my horizontal asymptote. And at this point, it's important to consider whether this is the horizontal asymptote whether this is happening as x approaches positive infinity, and if the same thing happens when I approach negative infinity. So think just very carefully for a second. If x is getting bigger and bigger, meaning more and more positive, look at my function here. That makes sense, right? I have a positive value up here and a positive value down here. So it makes sense that my horizontal asymptote going towards the right will be positive. But now think about what happens as x approaches negative infinity. So this is why I keep the absolute value signs. When x is getting towards negative infinity, what's happening? Well, this is going to remain positive because it is squared, but the denominator is going to be negative. So in fact, as I approach negative infinity, and this is why you've always got to consider both situations, as I approach negative infinity, it's actually going to approach -2 because the denominator is going to be negative. And so that's only towards the left. So I only need to really consider that when I'm moving towards the left side. And so we can actually kind of just forget about this part of the horizontal asymptote. This only works as we go towards the right. So now my sign chart, the only critical point that I have is when x is 2, to the left of it, my function is going to be negative, and to the right of it, my function is going to be positive. So first working towards the left, I know it is going to be negative the entire time, and it approaches this asymptote. And on the right side of 2, it's going to be positive and look like that.